So welcome to the meetup, Pratha, Hitesh, Ashutosh, Neeraj, Suja, Ankur, Sunil, Arnav, Chetan, Mohitesh. Uh, so, so ADG. So you're part of ADG currently. So what is ADG? So let me give you a small introduction. So ADG started back in our first meetup was held in 2018. Abhishek and Anuj were the founder of the ADG group, and their sole purpose was they didn't find anywhere they can share their thoughts. Bangalore had a very active community of various technologies, and the similar copy lacked in Delhi. And Abhishek and Anuj, in a way, sort of made their mission statements. Okay, why is it so? Why don't we have an active community in Delhi? And that is when which aligned with Abhishek and Anuj's passion, which is Android, and they created ADG. And its first meetup was held in Grover's headquarters in November 2018. And subsequently, we scaled. We tried to connect Abhishek. I guess I also met Abhishek in one of the interactions only at ADG only. And slowly I progressed like the corporate ladder, and I joined him as the co-organizer. So we have held various meetups in Zomato, ESmall, Oyo, Urban Glam. We are urban company now, Social Corp, Tokopedia, Expedia. This is when the offline model of networking was there. We were allowed to go to people and shake their hands, and that is when ADG was most active. Abhishek truly misses those days. Correct me if I'm wrong, Abhishek.
Yeah,
Okay.
definitely.
So we mostly share our in the information and activity through our meetup page, and our meetup page is 2,700 member plus strong, and there has been some addition. We haven't updated our numbers here, Abhishek. Maybe we should look at a number again. And we have a very active Slack group also where people come together and share their ideas, their work, and even if they're hiring for a particular position, the hiring, learning, sharing, and networking is happening through our Slack channel. So you can join the same. And we have social media presence. Our primary mode of information sharing is our ADG YouTube channel, where we share all our meetup so that people can watch them in the future also and can gauge what all we cover as a meetup group and in the direction that we take in, and also look back at the content and the quality of content through our YouTube page. Similarly, we share all the information through our active Twitter channel, and I don't think so we are very active on Facebook, but yeah, we are present there. The objective of, as I mentioned earlier in a joke, but it is a serious matter that we want to take, which is a build very active Android community. It is often hard, and offline was easier for us. People say getting people connected on online is easier because it's easier, they can join from their home. But we feel, and I guess Abhishek will reverberate the same thought. We used to like our offline meetups more.
Yeah.
So this is what our meetup used to last for 3 hours. First one round of 1 hour, first hour was predominantly the meetup, and next 2 hours used to be simple networking, people just sitting there and discussing ideas. Those were the golden days of ADG when we started. And we have focus on personal growth. We use the platform to give various newcomers and people who are even taking public speaking for the first time, and we work with them and try to, let's say, to inculcate a skill, how to interact on a public platform, what are the goods and nuances apart from the technical knowledge know-how. So this is also a personal growth platform that we try to build. And yes, you are in a way challenged in your thoughts by your peer about, you can talk about your work, that you can talk about the problem statement that you are working on. You can even talk about the thing that you want to adopt. Example, hey, my company is working like this. What modernization strategy I should take? Hey, my company is working like this. Should I adopt Jetpack Compose or not? All those kind of discussions are possible, and that is what the community stands for, I guess. And this is a small team behind it. I don't know why Abhishek has mentioned my name at the top, but he is the heart and soul of ADG. He does all the huge work, and he has been the person who is driving this community with a vision that one day there will be very active community, and we will not stop until that happens. And I'm very pleased to see the smile on Abhishek's face. He really does. Cool. We also have very active community managers. We have Ashish, who not currently Zoom has automated his job. Earlier in our offline model, we used to have our camera set up and we should take it around. He used to take care of the angle that he wanted to shoot and create these videos in our offline manner. And Shabazz. Shabazz also takes care of our Twitter and our Facebook mod. And obviously our speakers and our host who subsequently come session after session and take out the time, do the legwork of creating this presentation and hard work and take out the time to share it with us. So we thank you also. We would also like you, if you to spread the word, while you are in this call and you are learning from Rashanjyot, if you find anything very interesting and you want to say communicate to the world, like, hey, this is something I learned, or this is something I'm really inspired by, do share it also if you use Twitter, and tag us, and also tag Rashanjyot for sure, from whatever learning he's going to impart on us, and spread the word about what we are trying to do at ADG. So that's about ADG. Thanks for tuning. Rashanjyot, over to you.
Thanks a lot, Anupam, for that. I'll just share my screen. Is my screen visible?
Yes, yes. Visible.
All right, just to confirm now, is the screen visible now?
Yes, yes. Please go ahead.
Yes.
All right, cool. So first of all, thanks for joining in, everyone. I am Rashanjyot. To give you a small quick intro, I work as an Android engineer at OkCredit. And this talk, a very brief intro about this talk. So there's a lot of buzzword, and it's not been very recent. It's been quite a time that this MVVM, MVP, MVI, all of these buzzwords have been talked about in the industry. A lot of people have their different opinionated like takes on it. The difference, I guess, creeps in, especially in the Android ecosystem, because of the openness that you can implement the same patterns in a lot of different different ways. And it's not very strictly opinionated in terms of, for example, for reactive streams, we have so many options. For architectural patterns, we have so many options. And we are deriving some of the architectural patterns from, let's say, React or maybe some other framework. But that openness of the ecosystem also kind of allows the discretion to the end developer, causing that divergence in the whole sense. All right, so to begin with, I'll first talk about what are we going to cover today. So firstly, we'll cover with a very simple example as to why do we need architectures in the first place. This will be a total real life example. I'll take cooking for it. And I'll share a word of caution as to how do you choose that MV, whatever, MVP, MVVM, or some other that's probably going to come in the future. Then we'll talk about MVVM, but we'll only have a quick forward because I hope that everybody's pretty familiar with MVVM given its popularity right now. But we'll talk about the transition as to what MVVM helped with and how it was a great leap forward. Then we'll analyze certain code examples from MVVM to understand how does the state grow complex and when should you consider moving to MVI or whether you should not at any point in state. Then with that, we'll introduce MVI and its several components. I'll take those up at that time. Then we'll discuss certain concerns such as debugging, readability, performance, maintenance concerns, developer experience. All in all, we'll stick to the scope of MVVM and MVI for the preciseness of time and not talk much about MVC or MVP. So that's going to be. So let's begin. All right. So straight off, let's get cooking because that's what Indians are concerned about. Right, this is going to be the example as to why we should consider architectures in the first place. All right, so I guess all of us must be liking Manchurian and fried rice, right? But to have this lovely bowl of fried rice and Manchurian, you need to have all of these ingredients and procedures ready with you. Now, it will be painstaking. It will take a lot of time of yours and a lot of resources as well. But considering that you're great at collecting all of this, you've got all of these ingredients ready, you know the procedure and you're all ready. But what if your setup looks like this? Would you end up creating such a lovely bowl of Manchurian? I hope not. So very straightforwardly, that solution to that is, first you need to get things in order, separate different entities and group them logically. That's what you need. And that ease of access and utilization is what is the essential need of architectures in the software realm too. Uh, it's it improves readability, it improves ease of access, it improves your execution time in the long run, and will make stuff a lot more extensible, robust, maintainable, and testable in the software realm. Now, a word of caution, as if we understand what architectures are, after that, a word of caution is, let's say you want to make a very simple recipe. You want to make French fries at home. So you should simply get your ingredients, get your potatoes, salt and oil, chop your potatoes, fry them, and simply enjoy. One thing that I've really felt that sometimes there's a disconnect is, given these buzzwords, some people try to build this at home to get their French fries ready. So the problem lies in the premature optimization at times. So firstly, before deciding what sort of architecture do you want to go ahead with, a word of caution is, always foresee your use case as to whether you need it or not, and then apply it. Uh, if you're just learning it for learning, if you're going through it only for learning purposes, then that's great. But if you're probably applying this on some production level app, you should consider what your organizational scale is, how much bandwidth do you get for code maintenance purposes, what is your ratio of product to tech tasks, your overall team structure. Everything should be considered in terms of your use case, and then you should decide as to what architecture suits your needs. So every different project of yours might need another one. With that, now let's get back to Android and let's talk about code and architectures, particularly about MVVM. So a foreword as to why did MVVM, how did we land up with MVVM in the first place? So to revisit, let's quickly have a look at the differences in MVP and MVVM. If you look here, yeah, the only difference here that you can see is this is between these two arrows between the view and the presenter layer, right? So what used to happen was, in MVP, view contained an instance of presenter, and presenter, or maybe your view model use case, also contained your reference to the view. Now this created a lot of problems. First of all, this created tight coupling between the two. You cannot actually reuse your presenter layer somewhere else without any other view. There's some echo from somebody. Hello. Right. Okay. So another issue that used to be there was, you could not unit test your presentation layer. You would have to you would have to have instrumentation tests, which would have been much slower. So MVVM solved this issue. Also, the infamous issue of handling rotation, right? So MVVM solved this by only view having the reference to the view model or the presenter, but presenter not having the reference to the view. Also, with the advent of reactive programming and it becoming very, very popular, the implementation style of MVVM was pretty streamlined in terms of day-to-day applications and use cases. So let's have a look at the traditional implementation of MVVM once, so that everybody is on the same page. Let's say we have a simple to-do list application and a simple screen where you can add to-dos or see a list of to-dos. So in that case, you would perhaps have a to-do list activity where you would have the view model reference, and you would observe the list of to-dos in your activity. And the view model would actually look like this. You would have a repository or probably a use case in between, if not directly a repository, that would get the list of to-dos. And you would fetch those to-dos and set it to the mutable or live data or RxJava or Kotlin Flow, whatever you're using as a reactive stream. This is the traditional implementation, and so far it's so good, right? But now, where does the problem begin to happen? For that, we'll have to first understand and take an example of a little more complex scenario. Let's do that. Let's begin with an example. Let's say you have this simple screen where you earlier have a download button, and when you click on that download button, you show a progress bar until the download is complete. Now, pretty straightforward, but let's now also introduce an advertisement. For example, some other feature team working within your organization wants to show an ad whenever a file is being downloaded. So one thing to take care of here is that these are two logically separate feature pieces. Let's say one team is responsible for the success rate of file downloads, while other team wants to emphasize on advertisement. Though on the view level, these are still tied together in terms of when the ad would be viewed. So these are still totally separate in terms of how they're implemented in the business logic. Now let's see the code as to how would you implement this. In the MVVM example, let's assume that the file could be in either of these states. The download hasn't started, or it is currently downloading, or it has been downloaded. And in your view model, you would have something like an advertisement video, live data, or a reactive stream from RxJava or Kotlin Flow, where you have an advertisement video and you have the download file state. Now, next up, how would you handle this in the view model? When loading begins, you have to make the advertisement video available on the screen. And when the loading finishes, you have to take that off. Now, the first way, I'll start off from the worst way first. You handle this in the view model. How? Let's say when the download file action occurs, you set the loading state, wherein for the file download state, you set it as downloading. And for the advertisement video, you set the advertisement video object reference. But now look at it. Now let's look at it from a developer perspective. Let's say these two teams are operating separately, and let's say you're in the file download. Let's say you're in the team that's responsible for file downloads or developing this feature, right? So for you, this is a contextual overload. Why is this advertisement video live data stuff written here? Because essentially the function that called it was download file. So now this contextual obligation here. Hello, there's some background noise.
I'm good. Sorry.
Yeah. All right. So there's a contextual overload. Also, this results in tying and coupling of logic in the view model of two business use cases which should not have been there, right? So how do you deal with it? View model is not the right way to go ahead. So let's see an alternate way. The other one would be to handle this in view. You could have something like this, some sort of condition in the view, let's say your activity or your fragment, where you would check if the file download state is downloading and advertisement video is present, then you can show it. But then again, if you look at it, this is a conditional statement. And it's always great to have your views as dumb as possible, because your views should not contain any logic. So wouldn't it be great if we could extract this logic to somewhere we could test this in isolation, probably unit test this. So we've just figured that view model is not the right place and view is not the right place too. So how can we solve this? Essentially, we need to create a layer in between the presenter, which is your view model here, and your activity, which we'll introduce with the MVI structure pretty soon. Also, one another thing before in terms of what are the risks involved here, since there would be a lot of functions present in your view model which are actually mutating the states, multiple sources can actually affect the state. It can become cumbersome when the number of features begin to grow, and that state predictability and management becomes a hassle. If here a lot, some of you, I guess I'm pretty sure some of you must have dealt with screens which have a lot of features, a lot of growing number of variables. It often becomes messy to deal with. So what's the solution to this? Enters model view intent, which is MVI. Now, let's start off with this diagram first, because it will help you understand the intuition behind it. Let's start off from the user. So as a user, you use a mobile phone, you click on buttons, and that's what you do. That's an action or an intent. Also, something I would want to mention here is this intent is not the intent class that the Android ecosystem provides to us. This intent means the action or the will of the user to do something. So that's that. So when the user presses a button, he does an action. this fires or executes an event in the system. What it does is this intent is treated as an input to the presenter, which will process and then eventually will soon come to something known as reducer. This processing unit, something known as reducer, eventually updates your model or your view state, which is then observed by the view, and then the view renders itself and the user sees the result. So this is how the unidirectional flow flows in MVI. Right. So more than that, something I would want to mention here is that MVI in itself also requires a sort of a mental mind shift to think in terms of user actions and effects, and thus it becomes much more intuitive and makes the code feel more coherent altogether. While I would also want to mention that if you're modeling your data well enough, that's achievable in MVVM, but MVI makes it a little more intuitive in the long run when you're using it. We'll soon see how. Okay, so now back to our problem of handling the view level logic between two logically separated features, right? We had that add and we had that button. So how do you do it? We introduce that new layer called reducer in between presenter and the view. And now this reducer would only share one single object, a single state container, which will contain all of the data that is required by the view to render itself. So this reducer again, just as MVVM, in MVVM, view model is not aware of the view, reducer isn't aware of the view. So now let's have this is how a typical reducer would look like. A reducer in general takes in the current state and the intent, which is the action that the user has done, for example, a button click. And based on the current state and the user action, it decides and produces a final state, which will eventually be again listened by the view and rendered again. So it's like a state machine. Now we'll see how does that work. All right. Then next up, let's see how this would how our problem of showing an advertisement and the download button and then in the loading state would behave in the MVI structure. Let's say we have this state container. We first define the state container, which has an advertisement video. We're currently keeping it as nullable because it might be there, it might not be there. Then there's the file download status. And then the user intent is clicking on the download button, right? So then we write a reducer, which will always produce a state of type download screen state. And what it does is it will, for every intent, it produces a new state. So for example, in this particular case, when the download button is clicked, advertisement video would be set from wherever it is. I mean, this is just a sample piece of code, not a functional code. So wherever, and you could also pass this data along with the intent. Since intent is nothing but a sealed class, you could have data classes and pass data to it. So advertisement video would be set and file downloading status would be set to downloading. Now, how does this reducer help us? Since this is a middle layer between the view, which is the Android related stuff, versus the presentation layer. Since it sits in between, you can test this in isolation. This can be unit tested. Also, the great thing is when you are developing a feature as a developer, you don't see two features just because they are logically correlated on the view level. You don't see them together in the view model. So your business logic remains neat and clean. There's good amount of separation of concerns, and on the view level, the view remains dumb. So this is where reducer helps. Now, since we are talking about different states, let's see how does MVI actually correlate to finite state machines. I guess all of us engineers would have studied finite state machines in our college. So what it does is every time it takes an input, it processes it with the current state and results in another state. And one important thing to note here is the green start state. Just as every state machine begins with one state, it's important to know that in MVI also, whenever you will have a state, there will always be an initial state. Because intuitively, if you see, whenever you open up a screen, probably you would want to show a loader that we are loading a list, or maybe you'll show an empty view, because there has to be an initial state, right? So that is how you'll have to think of. Now talking about this initial state and reducer together. Before that, before talking about this particular slide, I would want to give this as a disclaimer. There are different ways as to how reducer and initial states are bound together in different implementations. Different libraries have different ways of doing it. This is in fact not the exact implementation that we are using in production at OkCredit, but this is a fairly popular one because you can refer to React and Cycle.js as to how this store implementation actually works. All right, back to this. Now here you create something known as a store. And then this binds together the initial state and the reducer will, as soon as reducer is initiated, it will use the current state as the initial state, and then it will start processing all of the user actions. Let's see how. So you'll have the current state, which is initialized with the initial state first, and then you have a setter. We'll come back to this later. So whenever there is a intent or an action on the screen, let's say the user presses a button, this process intent function would be called. What this does is it asks or requests the reducer to reduce the current intent with the current state. Then since this is a setter, this value would update. And also if you would see here, there is a state listener. Now, why do we need this? In MVVM, the objects that we share directly with the view via the view model, for example, view model or this live data, this RX stream or whatever, then that is you're sharing one single reference object to it for the whole lifetime of the view. That object reference isn't changing, but here, since the whole state container is changing, it's immutable. Its object reference would change. So this is a manual way of how you would set up listener and invoke it. Again, this is just one example. There are multiple different ways as to how you could expose state. I would encourage everybody to have a look at popular libraries such as MVRX, Orbit. Also have a look at how Redux and React do it, and Cycle.js, which was the origin of how this began. So there are different ways. Implementation, exact implementation detail down to the level would be different, but the concept remains the same all in all. All right. Now let's have a top-down view as to what we have discussed about MVI. Again, we'll start from user. Although we have already discussed it, let's close it. The user does an action such as a click. It fires an intent. This intent is then processed by the reducer and it updates the state. It gives you a new state. This state is then observed by the view, and then view is rendered to the user. Fair enough. Very simple and intuitive. Another mathematical way to put it is view is a function of model in terms that it requires model as an input to render the final view. Model requires the user action to update itself, and intents are being fired from the view. So this is that unidirectional flow that is achieved within MVI. I personally feel this is very intuitive by design because you start thinking in the direction of how the user does his actions and what are the side effects of it. So that's how it is. All right. Now, talking about the features of MVI and sort of mildly comparing them with MVVM, while also it's important to mention that some of these might be can also be applied to MVVM. And in my personal experience, the more I've had words with people from different organizations, they are somewhere using some mild version of MVI or a more sophisticated version of MVVM, where it somewhere sits in between absolute pure MVVM, traditional MVVM, and a pure MVI. So you can, it's just up to you. What sort of granularity do you need with it? Okay, so talking about features of MVI, one is the single source of truth. That becomes a problem in MVVM. Why? Because there's a lot of clutter of different variables that you've exposed to the view. So since there is a single container, it becomes a single source of truth. And another thing, since you have multiple functions that can mutate those live data or those reactive streams, the problem would be you would tracking and debugging becomes a little difficult when the size grows overall. Another thing to note here is that the view state, or the state as we call it here, is immutable in nature. This again can be immutable in MVVM in certain ways, but traditionally it's mutable because we directly mutable in the sense mutable in the view model layer, but we expose the non-mutable part of it to the view. But here, in every time you update the state, the object reference in itself changes. You will not have the same object that is just being listened to by the view. Another thing is unidirectional and streamlined action effect flow. This is again something that we have already discussed. Understanding the flow in terms of model as a function of view and intent as a function of model. Then separation of concerns. This is, I think, a big win in terms of how MVI solves problem of complexity and scalability. Since it excruciates and sort of extracts different layers and keeps things in different boxes. For example, your feature level presentation logic stays in view model or your use cases. The part of code where you're tying multiple features together in terms of view logic, that comes into the heading of reducers. And your view is simply a dumb layer that renders everything. So this is a huge win, but this comes at a cost. This comes at a cost of maintainability that we'll soon discuss. Another great thing about MVI is that since you have put everything into separate boxes, readability, testability, and scalability is something great when you're talking about complex and bigger projects and you're looking to handle projects in the long run of that scale. All right. Now there are certain drawbacks. I think some of them would be intuitive enough now that you have walked through the presentation. Some of them might not be. So one is complexity and learning curve. Of course, now that we have introduced certain layers, reducers, stores, all of this, and also in the end, we can also optionally talk about a little more sophisticated layers that you can add in between if these do not still suffice your complexity, but let's keep them separate for the moment. So complexity and learning curve is certainly one of those. It will take time to get up to speed with how this unidirectional flow of model view and intent works. Now the next two, which probably you will come to know when you start working with it, but is important to know, is object creation. Since we talked about view state being immutable, so whenever there is an update, there will be new object creation. So that overhead will certainly take some more memory, but again, this is as per your use case that you'll have to figure out if this works for you. I can mark it on my personal front that this object creation versus the performance hit that you get in terms of rendering issues is far smaller. That this with the growing technology and hardware that we have now, this has barely been a problem for us. We have never faced this for both personal projects or in production as well. Also, popular companies like Airbnb, Spotify are using MVI in this sort, but this is something that you should keep in your mind, and so that it does not alter user experience in any way. Another is dealing with one-time or single-time occurring events. This is not something we have discussed because we have not discussed this in terms of the code implementation. But intuitively, if you see, for example, you want to show a toast, right? Toast is a one-time event. But in case of view state, let's say you're updating some other state, you're updating the state of the button. But if you would have kept the state of toast in that view state, and it would have been unaltered because thus the other download button state has changed, in that case, what would happen is your toast would fire again. So you would have to manage those single events appropriately. There are again multiple ways to do it, and that is why I'm not going into the implementation detail. For example, with live data, there was something known as single live data. Otherwise, how we have done it, or some popular libraries have done it, is they handle view events as separate streams of data. That's how they do it. Now let's talk about certain common concerns that any developer would have while deciding any architecture, and this is where the actual difference or comparison kicks in. While I'm not opinionated about MVVM or MVI in any sort, I would just try to help you give an insight as to what would relatively be easier or harder when you're working with MVI. But again, it will boil down to the last mile implementation of how we have done it. All right, so first let's talk about debugging and testability. Debugging and testability is absolutely great with MVI. It's a step ahead. I'll tell you how. Since you have this single state container, it's always easy to log it and track it overall. And that's how debugging helps. You just have to track one state container, and your state is always living as one single unit. So you know that whatever your state is, your view would be analogous to it, and that's why you keep track. You can keep track of it in the reducer whenever that state changes, or maybe as and when you need it. In terms of testability, testability is again great too, because while in MVVM you can test your presentation logic in isolation and in as unit tests. Now you can also unit test the part of code in the reducer, which if it would have been in the view model would have been a bad developer experience that we talked about, because multiple features would have been tied together. If that would have been in the view, it would not have been unit tested. It would have to be tested via instrumentation tests. So now you can test the logic of how your view would behave given it has a current, if it has a state and an intent or an action is made by the user, and what would be the final state or the final behavior of the view. You can simulate that on the reducer via unit test, and your view could just be sitting as a dumb layer. Talking about readability, readability is great in the fact that there's a lot of separation of concerns. Everything is boxed together differently. But navigating, since you have multiple components, the size in terms of how much components do you have in each part would certainly increase. Talking about performance, as we mentioned from the drawbacks, object creation is something that you should and must take care of. But one important thing, and apparently since the whole community is moving towards it, so I would want to mention about Jetpack Compose. So Compose is increasingly improvising this aspect of MVI, to say, or that state machine that React has already been doing for quite a while. What it does is it internally checks for diffs and re-renders only those components where state changes. So again, that is why MVI really fits well with Jetpack Compose becoming really popular within the community. But as a word of caution, still do keep in check what your memory consumption is, how much heap is being consumed, and what object creation is. Also, you could probably verify those for multiple cases of yours, for in case of MVVM versus MVI. The last point of concern is extensibility and maintenance. This is certainly a hit, especially for smaller projects. The one-time setup and setup effort is quite a bit too, because there's quite some boilerplate you would see. You would have to maintain quite some base classes, and then implement certain reducers, or how you communicate back with the view. So, and similarly, maintenance effort is relatively higher too. Sometimes there might be some user actions where you're probably doing very simple stuff and you might feel a tad bit lengthy. So that way, extensibility and maintenance will take a little more of your effort from that end. But that being said, it really helps with projects that are scalable and have to see and have a lot of different complex components put together. So that's that. I try to cover all of the concerns. I would be more than happy to hear what your concerns are. So with that, that's that in terms of MVVM and MVI. Thanks a lot primarily for joining in, and feel free to reach out to me on any of these channels, email, LinkedIn, Twitter, for any of the concerns, not just this talk, anytime, anything you want to talk about. Right. Thank you so much. I think it's been a pretty long monologue. I would want everyone to talk about what their concerns are and anything that you have in your mind.
Cool. Let me play the devil's advocate here, Rashanjyot. Let's start with Amit. Amit, can you introduce yourself a bit, and can you talk through your journey and how much exposure that you have personally through MVVM, MVI, MVP, and whatnot, and anything that you personally liked or didn't agree to from what Rashanjyot has shared?
Hi, Amit
Yes.
sir.
Yeah, Amit.
So, I was just watching from outside. I'm in the market, but I just wanted to see the presentation. It was quite good. but I cannot speak much right now. So
No worries.
I'm in the outside.
No worries.
So sorry for that.
No worries. No worries. Uh, uh, let's have Pratha. I don't know if I'm pronouncing your name right. Don't kill me. Pratha, if you're listening to me, do you have any question for Rashanjyot?
Yes, Partha here. Thanks, Anupam. Thanks, Rajan. So one thing is right. So I know I worked with the MEVM, but I didn't work with MEV. I went to some of the presentations on the museum, but I still now I didn't get the difference. What is the difference when we move to that MEVM to the MEVI? I think today you explained clearly what's the when we have to choose the MEV. It's a really good eye opening for me.
Okay.
Thanks.
Do tag Rashanjyot whenever you ship your GitHub MR and moving to MVI.
Sure, sure, definitely.
Let's talk to, I guess, Nidhi. Hi Nidhi. Welcome to ADG. Do you have anything for Rashanjyot?
Yeah, hey everyone. So I work at Expedia, and I think I can relate to all the problems that Rashanjyot just shared, because we have been working on the MVVM and not really related to MVI, but we started using data classes to have all the outcomes of MVVM into our data class so that the view can easily understand, and eventually MVI was introduced. So we are also in that journey. So I could relate to most of the presentation and it was really good. Thanks, Rashanjyot.
Huh.
Uh,
Now, next question is for everybody, which is why being unidirectional is important. MVI, in a way, is a forcing function, uh, which in a way it makes sure that the data flows is unidirectional. If you understand data flow in your current application, is there any other way that you have personally tried? Maybe Nidhi, Ankur, Pravesh, anybody? Apart from like, hey, this is one more hack that I tried to make the data unidirectional. No, so I'll ask the same question to Russian. And then Russian, why can't we keep our data in check? Why making it unidirectional is the end goal that all these architecture are trying to achieve, be it through React's Redux infra or us learning from them and creating MVI.
Right. So like one of the core reasons is let's say you have the view layer and you have the presentation layer, right? Now whenever, let's assume the scenario that you're calling a function from the view to the view model, and it creates an effect, it leaves a side effect. For example, you call the view model function and it returns back a value to you which you're rendering on the view. Now this logic, this condition is residing on the view layer. So one of the reasons is testing views or Android views is hard because it's much slower to run instrumentation tests than running unit tests. So that is one of the biggest concerns that bigger organizations have, because when the complexity of a feature grows, there are a lot of different features put on a simple screen, right? It becomes a whole lot difficult to run instrumentation tests. Unit tests are way faster than instrumentation tests, and for larger projects it becomes mandatory at a point to do that. So that's one another thing. Also, that unidirectional flow helps you in terms of intuition as well. As it also sort of improves developer experience, I feel, because what it does is it helps you think of like, that this was what a user did, this was an action, this is the effect that it caused, this is the eventual result. So you think of things as repercussions. So that that very unidirectional flow that we thought that user is making an action, there is some change, then user sees back that result, it becomes much more intuitive when you're designing. So this is while I haven't been able to cover this because cover especially those writing those test cases with MVI, personally I feel writing tests with MVI is absolutely amazing. I'll tell you how. Because what you with the 3 A's of testing, right? What you do is you first set up your pre-required data, do some action, and then check whether what happened or not. So the tests that you write are readable in the sense that you write that this was the user action, you push an intent, you imply an intent that the user click this, you check if the button, and then you check and then you execute that reducer function, and then you check whether the button was now visible or not, or the state says true or false or whatever it is, right? So that testing becomes much intuitive. You sort of feel even while writing the code that you're a user of the app. So I think that is a developer experience plus point also.
Fair enough. And then Rashanjyot, I guess you will adhere to the fact that the reason these architecture, especially MVVM, took the forefront and become the go-to architecture for everybody was when Android was started and it was open source. Google never recommended a way to write a mobile application. It was with the Jetpack libraries. Then that is when they started, okay, hey guys, we will be using MVVM, and that is how it got adopted. If that tipping point hadn't come, I don't think so we would have been in a better shape as a community. Else we would still have been in the 2012 or 13 phase, when whatever you do, you can do in one single activity. So can you share your experience of what all architectures have seen? One of the examples I can give you is people have even tried to mimic MVI by using MVVM as the base and using Flow on top of it, so that you can create the experience of MVI through chain of events in the Flow instead of, let's say, directly using MVVI. So what all random architecture that you might have also seen? You can share your journey in terms of, okay, the costs and benefits that you had seen of having an architecture.
Right. Sure. So I have in production used MVP, MVVM, and MVI. But again, as I mentioned during the talk, that when I talk to a lot of developers who are working on products at scale in production, they are using, it comes from how they put it, their tonality as to they think that they're using MVVM, but they're using still state immutable containers and that unidirectional flow. So that line of as to whether it is MVVM or MVI, that line fades at a lot of times. I'll tell you why, because one thing that I want everybody to understand here is that MVVM and MVI are not two different directions. Think of MVI as an additional sophistication steps added in adherence to MVVM later. And it's not an enforcement that you have to have all of these steps enforced. And that is why I didn't even mention about, okay, now I'll do that. So for example, currently we just had actions and final state, right? Now in our particular code base, I can share a little bit about that, is we also figured there was another use case where just the current state and the current action do not suffice what's happening. There are certain partial states in between. In fact, if you look at how Orbit as a library, it's a very popular MVI library, just as common as Mavericks, which is MVRX. It has a concept of partial states. And then based on that partial state, you decide whether you want to do an action or not. So that granularity as to where you have to seep in those layers is totally up to you. You can begin from MVVM and add step by step to make it MVI. It's not that you'll have to do a lot of stuff to move from MVVM to MVI intuitively on design level. But again, it boils down to how your exact internal implementation detail is. For example, another thing I would want to show, I can probably share here is probably on the screen itself. Right. So this is MVRX, very popular MVI library. You can see that the view holds an instance to, is my screen visible?
Yes, it is.
This holds an instance to the view model, right? And similar to how I mentioned in the talk, you can have reference to the view model. But again, it's an implementation detail. In our particular use case, like code base, we don't even keep a reference of the view model directly accessible to the view. So you cannot call view model dot something. That view model object in itself, it's not there because this is to enforce strictness in terms of developer mistakes that can happen. For example, if you can still call view model dot something, that view, it's up to the developer to probably to have a return type there. What if it so it is sort of a miss in the peer review, right? And it creates a side effect because on code level compilation terms that can still happen. So in our case, what we are using is we are using a relay. For example, in the RX implementation, we are using relays. In coroutines, we're using flow. So we have an implementation where the base view models abstract this layer of intents and view this single side effects, which we call as view events. and then you push intents asynchronously to that relay, and then it consumes it. So cutting it down short, because this might be getting a little overwhelming to a lot of people. There are a lot of different implementation details. How can you do it? And that is why I'm referring to the fact that to get to the root of it, probably have a look at how React and how Cycle.js implemented, because that was the crux of how this all started. But then this started diverging in a lot of different directions. Now addressing your question precisely, Anupam, when you mentioned what architectures have you used. So I used MVP. It was a whole lot of pain to test my presentation logic. Then if I have to talk about as to how you progress, or what is the mental mind shift to progress from MVVM to MVI. For example, I'll be honest, in our app, there are very, very simple screens which are still probably MVC, like single button or like 2-3 button screen, which are probably not updated much or something, because MVI has some boilerplate, and that's fine. But okay, so what is the mental mind shift when it comes to transitioning, right? So let's say you're working with MVVM, you have a couple of, and this is very, very informally that I'm sharing, because mentioning that you have 2 live data or three instances, that's not the right way to decide an architecture. But very intuitively, let's say you have a few couple variables, and so far so good, you have been able to maintain it. But when multiple different features land upon a screen, there are multiple view. For example, let's say you have 2 buttons, out of which only one could be shown, and based and when when data of both of the buttons is not present, you have to show a loader. But as soon as one is shown, you'll have to show that. But there's also a priority list. So how do you do it? These are 2 different features, but those are logically tied. Those are logically different in terms of features, but logically tied in terms of views. So adding this to view layer would not make the view dumb. So that's a problem that you would still face in MVVM. You will eventually, if you want to test it, one is manual testing via QA and all of that. But if you want to test it via code, you will have to write instrumentation tests, and it's way, way slower. If you put this in view model, it becomes dirty, because then you would have to switch off that data of the earlier button. But that's not right, because otherwise, what's the point of using reactive streams and having the data ready to yourself? So that is where this middle layer of having reducer intuitively was a desire to do it. It was probably probably a coincidence that we landed up. This already had terminology from React reducer actions, and that is why I'm again emphasizing on the fact that everybody should go back and have a look, because once you know the forward and the history of why certain actions were taken, you can better understand what was the dire need to do it. But overall, MVI has been a bliss to work with. Once I've worked with MVI on production for quite some time now, I think I can't just go back, because while it does have certain components and learning curve is there, the very fact that everything is so neatly put. So basically, if you're that OCD person who wants to put everything in a clean manner at the right place, MVI is so much perfect for you.
Yeah, correct. I had a chance to talk to one of the other company, Kite. We discussed the architecture only in one of our podcast episodes. So they built a financial application. Now imagine the number of events that they have, and it only made sense for them when after they moved to MVI. So that I believe this is a gradual process, and an application goes through based upon its maturity level and what is the need of the application. But eventually, when things get too complex, you want to make some sense of it. Then the need of unidirectional flows is the crack that you had to go to. So we are out of time. So I guess in case anybody has any question, they can type in the chat. We'll wait for 20 seconds. Else, we'll break the session and we'll have a small networking session with everybody. No. In that case, thanks, guys. It's very good to see you all. A lot of people have joined for the first time. I hope you are part of our future meetups also. And thanks especially to Rashanjyot for doing a deep study into and taking the time and explaining what the nuances of these architecture are through use cases, so that everybody can understand. You can connect with him with his credential that he has shared for any question that you might follow up. We will post the session on our channels so that you can go through them again. Thanks, guys. Thanks for tuning in. Cheers.
Thanks a lot, everyone, and thanks a lot for joining in. Thanks, Abhishek and Anupam, for having me here.
Yeah, it's been a pleasure.